Hello everyone, my name is KS. In this video, I am going to explain about my lab experiment of computer graphics and multimedia. That is, representation of a pencil drawing using basic primitives. Basic primitives that we came across like line, circle, ellipse, polygon. So all these things. So as we can see in this picture, there is only basic primitives such as ellipse, semicircle, circle, circle, rectangle, rectangle. So these are the basic primitives. So I am going to explain how I did this. So let's get started. First I am considering this ellipse name it as ellipse 1. I am going to take a center by approximately keeping, so I can get the center coordinates at the end of the screen, left end, that is 431,80 as we can see there. And for ellipse we need 4 parameters, which is coordinates of the center, angle, coordinates, x coordinate of the center, y coordinate of the center, angle, and which angle to which angle, and length of A and length of B. So coordinates we got x coordinate, y coordinate 431,80. Now I am going to I'm going to show you length of A. Take it here. I dragged this point to this point, so the distance will be showed in the bottom of the screen, that is right to the coordinates, that is 3 into 38, because the 3 is like the width, it will increase, but the constant is 38 as you can see there, 38, the length of A is 38. And similarly the length of B can be displayed at the same place, 210. So the first ellipse, what are the parameters are being required? 0 to 360 degrees, because to need a complete ellipse, 0 to 360 degrees. So from which angle to which angle, lengths of both A and B, center coordinates, all this we've discussed. And next we will go to the semicircle. Actually it is not a exact semicircle in this representation, so I am going to consider it as an ellipse because it looks somewhat irregular. So I am going to consider the same center for this also, because to connect the endpoints, to get the exact connection between the endpoints, I am going to consider the same center and same length of the B. So only thing changes is length of A. So let's calculate the length of A. Length of A 433,86. Left to that 138 pixel. So we got the length of A. So what are the from angle to to angle, like from angle where 180 to 360. If you want the bottom top 0 to 180. So here in this diagram we are going to consider the only bottom of the ellipse. So from angle is 180 to 360, exact half. And let's get into the bottom. Here we can see 2 circles and 1 2 3 4 5 6 and 7 rectangles. Consider it as a rectangle because it is a 2D dimensional picture. Yes, we can see the 2 dimension, so view we can say it is a rectangle. Here again these 2 circles are look similar to ellipse only, so the same point, same thing. Consider the circle, length of A and the length of B, and angle default 0 to 360. Similarly this thing. And for rectangle, not only for rectangle, for triangle and everything, we are going to use one command, triangle, rectangle with many sides, irregular shape also we are going to use only single command, that is draw poly. That thing we will discuss later in the code. So consider the first polygon, take the coordinates, go in the clockwise direction, because while representing it will follow the coordinates. So go on, take the points clockwise direction or anti-clockwise, anything, but we have to get the exact shape. So like this you're going to take the points, point. Similarly point, this point. For all of this we are going to do the same thing. For these small circles we want to zoom in and we have to check although it not show the exact position, but we can get the approximate point so that we can adjust a little bit. Yeah, the as we noted all the points that is required to draw this diagram in the C code. Let's get into the code. So do C3 projects, card, open. It will take some time. Let's wait. This is the code. Open the code. So this is the code, and we can see the G driver, G mode. All these are basic things to initialize the graph that we needed, as we know that earlier. An error code, it is used to represent whether the graphic mode is uh, opened or not. If it is not opened exactly, so it will show the error that we can see in the bottom of the code. So these are all the points that we told. Follow the clockwise direction order or anti-clockwise direction order, anything, but follow the order. Otherwise the graph will get like swifted, like what we can say twisted graph. What I said, seven rectangles. For 7 rectangles we chose this 7, and initializing the graph. This is used to initializing the graph. Clear screen is used to clear the past thing, which is whichever it is present in the graphic mode. And error code, so this block of code is used to check whether the graphic mode is on or not. See, if it is not on, graphic error it will show, and we can get out of that. And 4 ellipses I told. One thing is bottom off and 3 full ellipse, and draw poly. This thing I told. So 5 sides, because we are represented a rectangle which has 4 points, but to complete the circle we have to show the 5 as it has 5 vertices. So I took 5 vertices in the earlier, and I placed it exact number 5. So 7 get, as we know, the get close graph, it closes the graphic mode, and we will get unable later. So let's see how it runs. Yeah, this is the graph. Although it is not as exact as the previous, we can see the exact diagram, but it shows some approximation, because we can't take the exact points which is there. We have to zoom in. Even though if you go through like zoom in, we can't get the exact graph. So I've tried my level best to get this look. So that's it. This is my lab exercise 1. So yeah, I'm finishing the video.